Solve sine 3x equals 0 between 0 and 2 pi. Now, I call these multi-revolution questions because we have either a horizontal stretch or a horizontal compression. And the reason they're multi-revolution questions is because that compression, if I compress this one by 1/3, well, instead of having one period between 0 and 2 pi, I now would have 3 periods between 0 and 2 pi. So we're going to first make some notes about some properties of multi-revolution questions. These are questions with a horizontal stretch or compression. And what I like to do is like a general solution, I like to first solve between 0 and 2 pi, and in this step, what we have to do as a step within this is change and I'll tell you what each of these things mean more clearly when we go to our example, but we're going to change the domain according to the horizontal stretch/compression. So we're first going to solve it between 0 and 2 pi, but part of that is changing the domain because of the horizontal stretch and compression. And then you can apply your solution to the given domain. Now, most of the time, the actual question does ask you between 0 and 2 pi, so your solution will just follow from that. Okay? Now, these aren't steps to solve it completely, but it's some things to consider when solving a multi-revolution question. So the first question that we have, okay, solve sine 3x equals 0. And the domain that was given to us was 0 less than or equal to x less than 2 pi. When the textbook does this, I'm just feeling like they're trying to be a little bit sneaky. Okay? I was reading yeah, it's a little geeky. I was reading an article about mathematical literacy today. I'm at an in-service this afternoon, and it was part of the required reading. But I'm a little bit geeky because I actually really enjoyed the article, and it was like super academic and yeah, anyways. But what they really focused on is how literacy is different in different subject matters. It's different to read a math question than it is to read a poem in English. You don't do it the same way. You don't read a chemistry question the same way as you read a math question. And one of the things that they pointed out in this article, and I said, that is so true, when you read a math question, you have to look at every little detail so carefully. In this situation, the fact that there is no equal sign with that 2 pi will become very important, right? If it's a 3-mark question and you didn't pay attention to that little detail, you would lose a half a mark on this question, which is 17% if you change it to a percentage. You can lose 17% because you didn't notice a little line. How easy would it be just to see the 0 to 2 pi and think, okay, and just rewrite it with that equal sign the next time you wrote it? So easy. So in math, we talk about how important it is not only to read a question once, looking at the details, but to read it a second or a third time, trying to sift through all the important information that's there. And I'll show you why that little line is going to be important later. Okay? So what we do in a multi-revolution question, and this was part of this first note that I wrote here in blue. First solve between 0 and 2 pi. Our question is between 0 and 2 pi. But change the domain accordingly to the horizontal stretch or compression. Okay? And what that means is you're used to solving questions like sine theta equals 0. That would be easy. So if we have sine 3x equals 0, well, if 1x is between 0 and 2 pi, 3x would be between what and what? And this is about changing the domain according to the horizontal stretch or compression. 0 and 6 pi. Does that make sense? If I got you to pick a number between 0 and 10, have it in your head, and then I told you to multiply it by 3, would it be fair to say that everybody's number would be somewhere between 0 and 30 after that fact? Right? There shouldn't be anybody who has a number bigger than 30, but I guess it could happen. Right? But if you pick a number between 0 and 10 and you multiply it by 3, all those numbers would be between 0 and 30. And so if x is between 0 and 2 pi, then 3x's would be between 0 and 6 pi. And so what this does, and I'll take out a unit circle here so we can visualize this as we go along. What this means is we're not just solving going once around the circle, but 3x's could be going around up to 2 pi, up to 4 pi, up to 6 pi, 3 times around the circle. And that's why I title these kind of questions multi-revolution questions, because sometimes you have to go around more than once. So then the question is 0 on your pi plate for sine? Is your y-coordinate ever 0? Yes. When does that happen? At 0, at pi, and at 2 pi? And so we can start by saying when you solve for a sine question, this is your angle. Your angle's 3x. So the 3x could be 0, it could be pi, and it could be 2 pi. Does that make sense for one time around the circle? Sine is your y-coordinate. It could be 0, it could be pi, it could be 2 pi. But we don't just go once around the circle for 3x. For 3x, we go up to 6 pi. So then the second time around, can you see that you would also have 3 pi and 4 pi? And the third time around, you would hit 5 pi and 6 pi. That does not look like a pi. Here we go. 4 pi. Third time around, 5 pi and 6 pi. Okay? And this is where that 17% could get taken into account. If you didn't pay attention to the fact that 2 pi is not included, which means that 6 pi is not included, this one doesn't get included in our answer. Would you agree with me that that's a very minor detail? Is it worth 17% of your mark? No, but that's what happens in math when there's like a little mistake is a half a mark, and if it's only out of 3 marks to begin with, that half a mark could account for 17% of that question. Okay, so with the multi-revolution question, the fact that there's a 3x inside instead of a theta means that we start off by saying 3x equals instead of theta equals. But now if you wanted to solve for x, how would I get x by itself? Well, the opposite of multiplying would be to divide by 3. So I take each of the 1, 2, 3, 4, 5, 6 different answers I have, and I divide them all by 3. And you could reduce that one to pi if you wanted, but it's not bad if you leave them all like that. And now our answers are all the answers between 0 and 2 pi. And since our original question was find them all between 0 and 2 pi, we're fine. We're done. But if the question had originally said solve between negative pi and pi, then you would have to take some of your answers out that are too far and add some negative coterminal angles in. So I'll do an example like that so we can see that. Now, part B to this question, okay, but I'm going to model. See, I'm on a whole nother page here, okay, but this is very typical of what happens when you do a math question. You finish the question. One of the things you should always do when you finish a question is reread part A just to make sure that we've done everything correctly. Solve 3x equals 0. We did that over the domain from 0 to 2 pi. We did that. It says give the roots to the nearest hundredth. Okay? They won't ask that on an exam because in this case you could get all the exact answers. But if we wanted to, I could change each of those to a decimal so that it was to the nearest hundredth. And if a question says to the nearest hundredth is how they want their answers, even though these answers are better, you should probably comply and change them all to the nearest hundredth. Okay, but I disagree. So instead of complying, I just changed the question. There we go. As exact values, then we're good. We don't have to change anything. Yes? No, unfortunately, when I give you a test, you're not allowed to go, oh, this one's really hard. Stroke it out. What is your middle name? Oh, I know this one. But the worst is when you change that question, you're like, oh, crap. I don't have a middle name. Have to leave it blank. Get it wrong anyways. Wouldn't that be nice? There are some times where you can change the question and still get most marks. If you change the question, sometimes students do this. They write down the question. They write down different numbers than the question actually was. Okay? Why you would want to do that, right? I don't know. But they see sine 3x, and for whatever reason, they write sine 8x. That doesn't make this question any easier. It makes the question almost exactly the same. They actually have an E error for this. It's E7. You wrote down the question wrong. But you solved a similar question of similar difficulty, so you would get all the other marks. If you decide to write down the question, it's sort of like, you know, you made it much, much easier, then you wouldn't get those marks. Or you don't show the things, like it's 17 times 19. And you're like, I'm going to do 17 plus 19, because that's better. Right? Although 17 times 19, 323, not too bad, is it? No? Okay. All right. Okay, part B, state the general solution. Two methods for the general solution of a multi-revolution question. Method 1. Method 1 is the same method that you would use for a regular general solution. solve between 0 and 2 pi. Then add plus 2k pi where k is an integer. So since we have already solved between 0 and 2 pi, that part's done. The only thing we would have to do to make this a general solution is write all the coterminal angles with all the angles we found. So our answer would look like x is equal to, big squiggly bracket. What are all the angles we found? We found 0, then there was pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and 5 pi over 3. Those were the 6 answers we found. And to make it a general solution, we could go plus 2k pi, plus 2k pi. Where k belongs to the integers. So if you have already solved between 0 and 2 pi, this is the easiest way to do the general solution. Yes? Well, 2 pi over 3 is in quadrant 2. 5 pi over 3 is in quadrant 4. If I add 2 pi to 2 pi over 3, I always end in quadrant 2. Okay? But yes, method 2 will make it more streamlined. We're going to get to not quite. Okay, but method 2 will do. Method 2 solve the general solution first for, I'm going to write kx, and then I'll just write specifically in our example, it's 3x, because inside the sign is 3x. We solve the general solution first. Wow, the solution kind of just went solution. Oh well. Then solve for x. So what does that mean? If we had this question, sine 3x equals 0, x belongs to, that's not an x, that looks like a k. X belongs to all the real numbers. And this was the question we had first. Option 1 would be first to solve between 0 and 2 pi, which we did to begin with, and then add 2k pi to all of our answers. Option 2 here says solve the general solution first for whatever you have inside. So my general solution would be 3x equals, when is sine equal to 0 from 0 to 2 pi? It's equal to 0 at 0, it's equal to 0 at pi, and it's equal to 0 at 2 pi. And if I'm doing the general solution first, I would go plus 2k pi, plus 2k pi, plus 2k pi. At this moment, I might realize the first one and the third one are the same. Does it make sense that that one is redundant? Because going from 0 and always ending at 0 is the same as starting at 2 pi and always ending there. All of those ones are going to be coterminal. So I start by solving the general solution, which says solve between 0 and 2 pi for whatever angle you have, and the angle that I have is 3x, and add 2k pi for everything. Then to solve for x, I would have to divide by 3. But when dividing by 3, 0 divided by 3 is still 0, but now I'm going to have plus 2k pi divided by 3. And I'm going to have pi over 3 plus 2k pi divided by 3, where k is an integer. Yes. I can scroll back up. Do you want to, I think this would be a good time to, no, that's too much. I'll just scroll up. Zoom page width, scroll back to method 2 right at the beginning. Is that good? And now a visual with your unit circle to help you see why both of these methods work. Okay? In method 1, we took our unit circle and we figured out all the places between 0 and 2 pi which had this answer. And we found out that it was at 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and so on. So these were our answers. In method 1, we listed all of these answers, 1, 2, 3, 4, 5, 6 of them. Right? Let's scroll up to method 1. Can you see we listed all 6 of those? And said, if I wanted all the answers, I could start at pi over 3 and add 2k pi, and that would give me all of these ones. And then I could go to 2 pi over 3 and add 2k pi, and that would give me all of those ones. And then I could do all of these ones. And then all of these ones. Ooh, and that's a big thick no. There we go, that one. And finally, all of those ones. That was my first solution. My second solution, by finding my answers from 0 to 2 pi first, and then dividing by 3 next. I'm going to get rid of some of those colors that I added, because now I start at 0, and if I add 2k pi divided by 3, that means you're adding 2 pi over 3, which is 120 degrees, over and over again. If I add 120 degrees once, I'm going to get here. If I add 120 degrees again, I'm going to get here, and then here, and then here, and then here, and then I'm going to get all of those ones. Can you see that I'm missing 3? But if I started at pi over 3 and added 120 degrees over and over again, then I would get all of those ones. And so this is a little bit more streamlined. And looking at the diagram, you might say, oh, but Mr. JR, I think you could add just even a little bit less and hit them all with one equation. So how would I think of that? How would I get that equation? Well, maybe if I go back to this part, and I say to myself, if I'm 0 plus 2k pi and pi plus 2k pi, could I write that all together? Can you see that you could just go 0 plus k pi? And I don't need that 0 there. I could just write k pi, but I put it there so that you could say, if I started at 0, then I could jump to pi, then to 2 pi, then to 3 pi, then to 4 pi. Can you see that this in green is the same as this in blue? And then if I wanted to solve for x, I just have to divide everything by 3. And then I'd start at 0 and jump by 60 degrees. Can you see that you would get them all if you kept doing that forever? Okay? And so as a mathematician putting the answer down, the last one circled seems the most elegant, the most You know, you write the least amount of information, and so it seems nice. The nice thing is you do not need to be elegant in this class. You can flop around if you want, and I find that most students, because a lot of these questions ask you to first solve between 0 and 2 pi anyways. Most questions ask you to first solve between 0 and 2 pi anyways. It makes more sense just to take those answers and add 2k pi and be done with it. And not worry about elegance, because for the most part, a lot of you are like, I just need to get through this course, Mr. JR. That's all I need. Yes, I would love to understand everything, but I know that that's not going to happen for me, and I just need to get through. So then method 1 is really nice, because you just have, it's really simple. But if you like the elegance, the beauty of mathematics, then some of those other solutions are really nice. Okay, I said I'd do another example. We'll add one here. We'll do it from okay. Picked a nice nasty looking domain there from negative 3 pi over 2 to pi over 2. Can you see that that's still just once around the circle? But the only positive angles are quadrant 1. And then we're only thinking about negative angles from quadrants 4, 3, and 2. And then B, we're going to do the general solution. So for A, we're going to solve first just once around the circle from 0 to 2 pi. So if I did that, well, my theta is between 0 and 2 pi. Then 2 thetas would be between 0 and 4 pi. Twice around this circle, which makes it a multi-revolution question. And if I was solving cos 2 theta equals negative root 2 over 2, well, then we would say the angle, which is 2 theta, equals. When on our unit circle do we have negative root 2 over 2? Okay, what family? Pi over 4 family. What quadrants? If it's negative, quadrants 2 and 3. So I know I'm looking for my pi over 4 family members in quadrant 2 and quadrant 3. So that will be 3 pi over 4 and 5 pi over 4. That's once around my circle. The second time around my circle, I'm going to hit those values again. How do we figure out what is coterminal with 3 pi over 4 the second time around? How do I know that it's going to be 11 pi over 4 mental math? What did I add? I added 8 plus 3. Why did I add 8? Because if I'm adding 2 pi to this, 2 pi is the same as, well, I need a common denominator, 8 pi over 4. So we add 8 in this situation because it's pi over 4. If it was a pi over pi over 6 initially, when you add 2 pi, you'd have to add 12 pi over 6. So it all depends on what your denominator is here. I'm going to add 2 pi to that one. I'm going to do the same thing with this one and add 8, 13 pi over 4. I'm actually adding 8 pi over 4, but what ends up happening in your numerator, you're just adding 8. So those are the 4 answers between 0 and 2 pi then between 0 and pi, solving for theta, theta would equal 3 pi over 8, 5 pi over 8, 11 pi over 8, and 13 pi over 8. Make a little note here. This was between 0 and 2 pi. Our domain was supposed to be between negative 3 pi over 2 and pi over 2. How can I look at this and say this one's okay and these three are not going to work? Mental math-wise, how do I know and see that right away? Okay. What's the biggest positive number I could go up to on these ones? Because I can go up to pi over 2, and pi over 2 is equal to 4 pi over 8. So can you see that that's why 3 pi over 8 is the only positive one we could have? Does it make sense that this answers in quadrant 2, this answers in quadrant 3, and this answers in quadrant 4? And so now we need to find out, since negative 3 pi over 2 less than theta less than pi over 2, one of the things that I often do when I get a domain like this, I think of my unit circle. I think of pi over 2 being here, 0 there. This would be negative pi over 2 and negative pi, and this would also be negative 3 pi over 2 or pi over 2. I'm looking for positive angles between 0 and pi over 2, and I'm looking for all the negative angles between 0 and negative 3 pi over 2. So I'm going to write them in the same order that I have here. 3 pi over 8 instead of 5 pi over 8. Can you see that that is negative 11, negative 11 pi over 8. Because if I went to that angle in quadrant 2, it would have the same reference angle of 3 pi over 8. And this idea of reference angles comes back over and over again. We're going to go pi plus 3 pi over 8, and pi is the same as 8 pi over 8 plus 3 pi over 8 would give me 11 pi over 8. I'm going in the negative direction, so I would write that as negative 11 pi over 8. 11 pi over 8, which ends in quadrant 3, would be the same as negative 5 pi over 8. And 13 pi over 8, which ends in quadrant 3, would be the same as negative 3 pi over 8. So now we have solved this with the given domain. We do a little bit of extra work with coterminal angles. Again, use our reference angle to figure that out. So that was a nice review of those concepts built into this question. Part B said, find the general solution. Method 1 said, take the answers you had between 0 and 2 pi. Theta equals, we had 4 answers between 0 and 2 pi. They were 3 pi over 8, 5 pi over 8, 11 pi over 8, and 13 pi over 8. Add 2k pi to each of them. Where k is an integer. And we can see why people like method 1 if they've already solved it between 0 and 2 pi. You can just add 2k pi to each of those answers and you're done. People like method 2 if they haven't done step A. If the question was just solve cos 2 theta equals negative root 2 over 2, you would start off by saying the general solution. I know that this is in quadrant 3. It's part of my pi over 4 family in quadrant 3 and quadrant 2. So I'd write 3 pi over 4 and 5 pi over 4 plus 2k pi plus 2k pi, where k is an integer. And then to figure out what theta would be, I divide everything by 2, so I get 3 pi over 8 plus k pi, divided that by 2, and 5 pi over 8 plus k pi, where k is an integer. So my answer is more streamlined. And if we look at this visually, okay, my first answer here says on my unit circle, here's 3 pi over 8, here's 5 pi over 8, 11 pi over 8, and 13 pi over 8. Those are my answers. And I would do each one of those 4 separately by adding 2k pi. In the second solution, and I'll color code this differently, here's 3 pi over 8. Here's 5 pi over 8. And if I add pi as many times as I wanted to 3 pi over 8, that would get this one, then 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 this one. And if I would add pi to 5 pi over 8, those would get grouped together. And it gives you the same solution if you did all the integers. It would give all the coterminal angles of all of those angles. Just one has to write 2 things, the other one has to write 4. But both are accepted. Okay? So if you've done part A, method 1 is much simpler to do because you just have to add 2k pi to each of them. If you haven't done part A, you might want to do method 2 because it's shorter and simpler. Okay? If knowing 2 methods is too much, your brain has a limited capacity for remembering things, then you might just say, I'm always going to do method 1 every single time because that's easier. Question for practice number 10.